And just a couple seconds to give you links on these slides, so you can open it when I'm talking, just in case if you want to browse it back and forth during webinar. So today I want to focus on high availability questions. I personally define the current MySQL stage as stage of high availability solutions. While there are a lot of materials how to set up and tune and optimize a single server, high availability for MySQL is still on initial but rising stage. You may see an increasing interest to many third-party software like Continuant, MHA, MMM, Flipper, Percona Replication Manager, and like that. So what is high availability? Availability refers to ability of the user to communicate and access the system, submit new work, update or change existing work, or collect the results of previous work. If a user cannot access the system, it is said the system is not available. And word high refers to some prearranged level of performance during a long period of time. You probably heard the expression 5 nines, which shows that system is available 99.999% of the time. And the usual approach to provide availability is to have redundant systems. It is especially useful for a system like web server or application server. Basically, we just duplicate resources, and failover procedure is very simple. When one system is down, we redirect user request to second system. It applies actually to more than two systems. Having multiple servers for redundancy, we can manage the probability of failure. If a single system has a probability P, then the two servers have probability P divided by 2, and for X servers it is P divided by X. Or graphically we can see this is an inversely proportional function. The more servers we have, the less probability of failure. And was it easy? Well, it is, but not if we deal with databases. Database is more complicated. There are actually two parts: system, server by itself, and data. And beside the system redundancy, we need to provide data redundancy. And to provide availability for database, we need to provide availability for two components: servers plus data. This is where replication come into play. The replication is a process of sharing events between resources. When one of system updates data, it informs other systems. And MySQL replication is, of course, most known in MySQL world. And when we speak availability based on MySQL, I have this picture in my mind. This system works, but it has they have many kind of live support elements, and if you do something wrong, your system fails. Well, yes, I exaggerate this a little, but I'm doing to draw your attention. There are a lot of MySQL replication setups which are to serve HA purposes, and they are doing a great job. And what is wrong with it, I will explain myself just in a couple minutes. MySQL replication is a great tool, and it is simple to understand, and this is what made MySQL and MySQL replication very popular. And MySQL replication is one of the factors why MySQL is the most popular open source database. And for example, lack of good replication system was the biggest issue for Postgres users. So what is wrong with MySQL replication? This is as simple as A in asynchronous. MySQL replication is asynchronous. Asynchronous means that there is no confirmation or guarantee when event will be applied on a replicated system. By its nature, it assumes that there is a delay between a slave and a master. And the delay can be microseconds or maybe hours. In a simple term, asynchronous does not guarantee that your data is the same at a given point of time. And the synchronous communication is different. It assumes a confirmation process. The first systems are waiting on confirmation. And did not we just reinvert DRBD? Yes. However, with DRBD we have different problem. While data is always available, the system is not. Remember that picture and the start of presentation when I said we need to provide availability for two components, systems and data. And the DRBD only works in active-passive mode, and the system is not available for a given point of time, and file over might take time. It depends on many factors, but in any case, it cannot be zero failover time for system based on DRBD. And on this step, we are coming to clustering solutions. And namely, our solution, Percona XtraDB Cluster. As usually, our software is free and open source, and you're free to install it, to use, uninstall, copy, distribute, provide commercial support, write books, and do whatever you want with Percona XtraDB Cluster. In XtraDB Cluster, the nodes are connected through group communication, and inter-exchange events synchronous. Well, in fact, the process is not fully synchronous. It is virtually synchronous. I will not go in the details. It is a very complicated process. It's maybe separate webinar on this topic, but the short explanation you can find by Wikipedia link. And I actually tried to simplify the process, and this is simplest schema I could come up with. The important point there, the network interaction happens when you issue commit statement. At this time, the node performs network communication and certification of transaction. On intercontinental communication between nodes, the network round trip can be significant. For example, 200 milliseconds on nodes between Amazon California and Amazon Europe availability zones. And also important to note that slave still can be a short period of time out of sync with master. The difference comes from the fact that applying event on slave might take a bit longer time than a commit of master. Well, in any case, we speak about microseconds or second in worst case. The delay can not be very significant. So there is a list of benefits that the XtraDB cluster provides. First is synchronous replication. The importance of synchronous replication I already covered. Second, multi-master replication. In a regular MySQL replication, writes to several servers are possible, but most likely you're looking for big troubles. This comes from the fact I already mentioned, being asynchronous. The second server may be behind, and updating server which behind you might update stale or not relevant data. With the XtraDB cluster, it is different. You can update any server in the cluster. You can you can do work with any node in cluster. Third benefit is parallel replication. We can apply events in parallel. It is a well-known limitation in MySQL that slave is only single-threaded, and it is an additional factor why slave might get behind master. On modern servers with 32 cores, the master can perform much more updates per second than the slave with single thread can handle. In XtraDB cluster, we actually can set up a slave that it can perform events and deploy events in defined parallel threads. Fourth benefit is data consistency. In XtraDB cluster, we guarantee that data is equal on all nodes. A transaction is either committed on all nodes or not committed at all. And the fifth is automatic node provisioning. When one node joins the cluster, it automatically copies data from an existing node. Finishing with the benefits, I want to give some attention to CEP theorem. You probably heard about it. It especially applies to different popular NoSQL distributed systems. I will try to use it to explain the difference again between MySQL replication and the XtraDB cluster. I will simplify the theorem to next statement. In the distributed system, you can have only two from following choices: data consistency, node availability, or partition tolerance. I understand that it still sounds somewhat fuzzy, and let me show you following example. Imagine in a system with 3 nodes, we have a network failure to one of nodes. In case with a MySQL replication will provide you access to all nodes. Even the node disconnected from other nodes, you still will be able to connect to MySQL locally or through available network connection and extract and change your data. However, you understand the node will not receive updates from system 1 and 3. That means that data consistency is compromised. With the XtraDB cluster, we guarantee data consistency, but as a downside, we cannot allow access to node that is disconnected from the cluster. As a consequence, minimal recommended configuration is 3 nodes. Why? Let's see what we have with 2 nodes. In a 2 nodes configuration, in case of link failure, we have a case which has a special name, split brain. We cannot pretty much decide which node accepts queries and which is not. And what happens by default, in this case, both nodes will refuse connections. We still, however, have a special option that allows you to have this schema, but you basically take responsibility on yourself. You need to make sure that you have only one and only one master, that is server that performs updates queries. Once again, back to our theorem, it shows a principal difference between MySQL replication and the XtraDB cluster. MySQL replication provides you an access to all systems. XtraDB cluster prioritizes data consistency. And this applies to all external software and scripts that based on MySQL replication. As long as a MySQL replication is asynchronous, it does not guarantee data consistency. On this stage, I wanted to give a little more details about XtraDB cluster. Percona XtraDB cluster is all good Percona server plus special replication patches plus Galera library, and the Galera library is developed by Finnish company Codership. In fact, the fact that XtraDB cluster is based on Percona server, which is compatible with MySQL, means that XtraDB cluster is fully compatible with MySQL setups. You can use the same NDB storage engine, and database server behave the same way. Queries have the same execution plan, and you use the same configuration, the same optimization techniques as for regular MySQL server. There are minimal efforts to migrate from existing working system to system running XtraDB cluster. It is not much harder than just upgrade from MySQL to Percona server. If you did it before, you know that it's quite easy. You just replace all the MySQL binaries by new binaries, and for XtraDB cluster you will need to make a couple changes to configuration file. And also important, there is no lock-in. If you don't like our solution by some reason, there is always an easy way to return to previous setup. You just downgrade to MySQL replication, and you have your system working all the familiar way. This all sounds so good. So is this a perfect solution? Yes, I want to answer yes, but I guess you won't believe me. And of course, there are some limitations. It is a new product and a new solution, and there are limitations. Some of them will be resolved later, and on some of them we are working, and some are just a limitation by design. The first limitation is that only INDB tables are supported at this moment. Changes to my ISAM tables will not be replicated, and so you need to make sure that you have only INDB tables when you test XtraDB cluster. My ISAM support is under development and will be available later, I guess, this year. Second limitation is in compatibility for applications. This limitation is that XtraDB cluster introduce optimistic locking. This locking is applied not to all cases, but to transactions that running on different servers. Let me explain what does it mean for you. First, traditional INDB locking for transactions on the same server. When two transactions are trying to update the same row, the second transaction waits until first transaction perform commit or rollback, and only after that second transaction performs. In XtraDB cluster, running transaction on different servers, like in a multi-master case, we actually can get an error on a commit statement. Once again, this applies for different servers. If we run a transaction on the same server, we have traditional INDB locking, and on different servers, it is optimistic locking. Two transactions are running in kind of lockless mode, and they assume there is no conflicts, and later, only on commit stage, transactions are communicate one with each other. And again, we have this model because all communication happens on commit stage. So if on this stage transaction 2 finds out it updates a row that also updated by another transaction, then transaction 2 will need to perform rollback and return error to client. And this is not something that usually happens in traditional applications based on MySQL. And your application actually may not be ready for that. And it is fair to say that many applications or frameworks do not handle errors or on commit query. And this might require changes in your application logic if you expect to run transactions on different nodes. I understand it may be big in compatibility, but I hope this one and only one significant change you might need to perform when you run XtraDB cluster. Okay, next limitation. Write performance is limited by weakest node you have. This is price we pay for data consistency. If one of our nodes becomes suddenly slow by a different reason, some like a disk failure or a RAID battery, write queries are equally slow in the whole cluster. Let me show why. When a user runs update on one of servers, this write event is communicated to all nodes. The user gets confirmation after server gets confirmation from every node. If one of nodes is slow, the whole cluster is slow. Now let's talk about write-intensive application. Write-intensive, I mean very high rate of updates, inserts, deletes per second. If you have this case, there will be some limit of how much data you can have in your cluster. And this limitation is not physical. There is nothing hard-coded, but it is rather logical. Let me explain why. And in parallel, I also will explain how cluster handles join process. Let's assume one new node wants to join existing cluster. As we already discussed, it has to have full copy of data, to have the same data as other node in the cluster. So what happens in this case? Cluster allocates one node which gets status donor, and the joiner copies a whole data set from donor. You understand that, for example, for 200 gigabytes of data, it might take time to copy it over network. Meantime, donor is also gets out of cluster. It might be a short or long period of time, and it depends on what copying method you choose. I will show you different copying method later. Now, when data copying is finished, we have two nodes that were disconnected from cluster, and they need to apply events that happened while they were disconnected. If you have big database and if you have an intensive rate of changes, it might take actually a long time. And while events are applied to donor and joiner, new events might still happen in cluster. You understand that these two are trying to catch up, but cluster generates new events. In the worst case, these two outsiders might never catch up. So for a very intensive write application, this should be hardware plus software solution. This is the case which we cannot solve only using software. And this applies actually not only to XtraDB cluster. Let me show you some analogy. Let's take a single InnoDB system. When we need a good write performance from InnoDB, the usual setup is to have disk array. You cannot have decent performance with a single disk. And if you have good InnoDB write performance plus ACID requirements, if you need durability, you need not only just disk array, but array with a cache which is backed by battery. The same applies for cluster. For write intensive application and good performance in cluster, you will need a good network solution. I recommend to look into like 10 gigabit or InfiniBand connection, and a good storage SSD or PCIe flash is a good choice. Okay, give me 1 second. Let's back to join process. As I promised, let me review methods XtraDB cluster can use to copy data. This process by itself has special name, state transfer. And the XtraDB cluster, we have two state transfer. This is a full data copy. This is a snapshot state transfer. It happens when a totally new node joins cluster, or a node was in the cluster, but then by some reason it was disconnected for a long period of time. And the second is incremental state transfer. This happens when a node was disconnected for short period of time. For a snapshot state transfer, full copy of data, we have following choices. This is a MySQL dump. Obviously, it is good for small databases, or if you want just to play with initial cluster setup. Second is rsync. The data is copied using rsync process. Usually, it is the fastest way to copy data, but the drawback is that donor is disconnected from cluster for whole copying time. And the third choice, extra backup. In our new extra backup release, extra backup 2.0, we support state transfer for XtraDB cluster. With extra backup, the donor is disconnected for a very short period of time, but copying data and joining might be slower than using rsync, because we perform additional data consistency checks, and also joiner will need to perform apply process, which is similar to InnoDB data recovery. And the incremental state transfer is used when a node was in the cluster, but we had it put down for a short period of time, like server reboot or some change of some configuration parameters. And the second case when it can be used, but not right now, it is when node crashed. Yes, it still happens, MySQL can crash. Unfortunately, at this moment after the crash, node has to perform full snapshot state transfer. This is a limitation which we are and the codership working on, and the incremental state transfer after crash will be available in following releases. And at this time, now I would like to continue with scalability topics. Scalability for me is quite similar to availability. This is why we can use XtraDB cluster for needs to scale scale our load. Scalability is similar to availability in a sense, how it can be handled by redundancy. In this case, only difference is that the first system is not able to handle user's request, not because it is down, but because it is overloaded. And the experience actually for end user is the same. The system refuses to handle his query. The system is not available for the user, and it can be handled by redirecting query to second system. In the XtraDB cluster, it is easy to scale reads. Reads queries do not require additional overhead or group communication. Scaling writes is a more complicated problem, as each write has to be replicated on every system, and each server has to handle writes coming from all servers. This is I explained before how a write request handled by cluster. So we can make some rule of thumb. It is very approximate, just to get a basic understanding how to look into. If you have n servers and our workload is 100% reads, we can scale as much as n factor, and for 100% writes, we can scale only to some constant or even cannot scale at all. So if you put some numbers in that equation, so and if one server can handle, say, 100 read queries per second, then 10 servers in the XtraDB cluster will be able to handle 1,000 the same queries per second. For 100% write traffic, there is no much room to grow because of internal communication I showed before. If one server can handle 100 updates queries per second, then 10 servers still are able to handle only 100 the same queries per second. Actually, it can be a little better because internal communication happens in an optimized way. The servers does not need to parse the same query several times, and also because of virtual synchronicity, it may be better than scalability factor 1, but it's still limited. I'm talking a lot about XtraDB cluster with different engineers and different group of people. I see a lot of interest, and I receive a lot of questions, and the most popular questions I would like to address also in this webinar, just in case if you also have them. So one of the questions I received, so it looks so easy. Why didn't you implement before, like maybe 5 years ago? And I should say, actually, it might look easy, but actually it is not. This is a computer science and academic research based on group communication and distributed transactions. And I need to give full credits to Codership company. They done all this heavy lifting job on this topic. Another question: how fast is it? Actually, I think it is reasonably fast. Yes, we still have this all group communication of our network in synchronous processes, and as I said, there's some techniques like certification and virtual synchronicity minimize that overhead. And if you look at two performance characteristics, response time and throughput, the response time, this is the one that might take hit network round trip for sure will increase the response time. If it is critical for you, you make sure you have a decent network and storage. And the throughput is less affected. You can do, as we can do a lot of operation in parallel, we can have reasonable performance numbers for throughput. Next question is, can I replicate XtraDB cluster to MySQL replication? And answer is yes. You can have some setup where you have a different system on a different cost, and because of network round trip having this setup as synchronous, it might add a lot of latency to queries, so that you can use actually asynchronous MySQL replication setup. In this case, you can asynchronously replicate one cluster to another. Next question is, would I personally install in a production system? And my answer is yes. I'm going to update MySQL performance blog and Percona.com to use XtraDB cluster very soon. Next popular question is how it is compared to MySQL cluster, and my answer is different. I mean, it is a really different system with different goals. How you can compare it, but usually people do not like this answer, and that's why I put this marketing-like spreadsheet with checkboxes, solitary. I need to say. Yes, so there I compare XtraDB cluster characteristic with MySQL cluster characteristic. So with XtraDB cluster, it is easy to migrate, easy to use, and you actually can use it in cloud and EC2 environment. With MySQL cluster, you might need changes in the application, and the changes may be very significant. But on the other hand, you actually can use MySQL cluster for write scaling. MySQL cluster is designed to scale writes, and as you remember, I mentioned that write scaling may be problematic for XtraDB cluster. And MySQL cluster can provide your 5 nines high availability. This is actually a good question, how many nines XtraDB cluster can provide. I do not have a good answer on this one, but potentially I don't see why it cannot be 5 nines also. And I'm getting to the end of my webinar. There I put some links on resources which you might find useful. There's documentation pages, page with XtraDB cluster, and links to Wikipedia for some theoretical topics I touched in during this talk. And again, I should give credits to Codership company, which developed all replication and Galera library patches. And Terry, on this stage, that's all from me.
Okay, very good. Thank you, Vadim. Couple other items to mention. For those of you attending the MySQL conference and expo next week in Santa Clara, Vadim will also be presenting on XtraDB Cluster, where you'll have a chance to interact with him directly, and he will also be at our booth at the conference on Wednesday to answer questions. So please, if you're coming to the conference, feel free to stop by and speak with him directly. We have a number of questions for you today, Vadim.
Okay.
And you may have covered some of these already, but I'll go through what we have here. And we'll start with, does synchronous replication mean that the performance of my MySQL server drops in insert, update, delete queries per second?
Again, I tried to answer that question during the webinar, but let me try to touch it again. Again, it is not fully synchronous process. It is virtually synchronous, which actually helps to reduce latency for insert, update, insert queries. And again, yeah, latency might increase, but in my benchmarks, it is not that big to worry about. And again, on MySQL User Conference, Codership team will present their benchmarks. So if you're not going to attend conference, the slides will be available after the conference. So you will be able to look on numbers, and also we in Percona in our lab working to show you some benchmarks, and actually some benchmarks are already available on MySQL performance blog. So you might just search XtraDB cluster keyword and look on numbers that are already available. So there some performance hit. If you're looking for a single system, you may see increase in response time, but we actually can load a system in parallel, several nodes, and in that case we actually can see performance increase.
Okay, very good. Next question is, how are auto increment columns handled in multi-master?
Okay, yeah, this I should put this question to my frequently asked question. This is a popular one. So answer is that XtraDB cluster setups auto increment offset automatically for each node. That means you will have a different offset on each node. For example, if you have 3 nodes, first node will have a ID like 1, 4, 7. Second node will have ID 2, 5, 8, and the third node identical way.
Okay. Next question is, can you have an arbitrator in place of a full data node for the third node in a minimally sized cluster?
Sorry, Terry, can you repeat the question? I don't fully.
Sure. The question was, can you have an arbitrator in place of a full data node for the third node?
Okay. Yeah. Yes. There we can set up some dummy process instead of fully node that will act just as a arbitrator that will allow to make a decision which nodes to keep in cluster and which nodes to throw from cluster. So yes, there is such a possibility.
Okay, very good. How are temporary memory tables handled?
Temporary tables are right now only on local nodes. So temporary tables are not replicated, but we have work in progress to be able to replicate temporary tables in memory also. Again, at this stage, only InnoDB tables fully supported. some memory tables, which are temporary, are not fully supported at this point of time.
Okay. How does XtraDB know that a node fails, and how fast is it removed from the cluster?
It is based on a timeout, which you actually can configure in your system. So by default, it is a couple seconds. Again, communication happens on commit stage, and if on a commit stage, cluster figure out that some of nodes does not respond on that commit communication, that node is being thrown out of cluster, and the decision is made based on a quorum. There are more nodes which are connected together. They get a bigger priority.
Okay. How do I connect to a VIP?
For VIP, there a couple of solutions can be used. Actually, there are a new PHP library and a Java library which can emulate work with several nodes. It's not directly VIP, but it can be used instead of VIP solution. And also you can use HA proxy. We provide the scripts and the basic guidance how you can set up HA proxy to use as a load balancer in front of cluster. And also Codership has their own load balancer which you can use for that purpose.
Okay, the next question is about applying table changes, and the question is, can one node be taken out of the cluster, changes applied, then made the new master while the slaves catch up?
Sorry, Tali, can you please repeat that question again?
Sure, so the question is, can one node be taken out of the cluster, can table changes be applied to that node, and then can that node then be made the new master while the slaves catch up?
The answer is yes. This is where incremental state transfer can come into play. So while one of node is temporarily out of cluster, and when it joins the cluster back, it can apply changes which happened to cluster incrementally. But again, when you perform update, you need to make sure what you're doing, because if you update data in that table, that you might get the case when your data is not consistent. And this scenario actually can be used for a schema update when you need to perform alter table, for example, to add or to remove index. We name it a rolling schema update, and it is supported.
Okay. Next question is about MyISAM tables. The question is, what happens to them, and would it be better to change them to InnoDB?
So for MyISAM tables, right now, they changes. If you update MyISAM table on one node, that change is not replicated to other nodes. So basically, you will have different data on different nodes if you have MyISAM tables. And our general recommendation is Percona. Yes, in general case, you should use InnoDB tables instead of MyISAM. Of course, there are some kernel cases where MyISAM is more preferable, but that is usually some only special cases.
Okay, next question is, can you talk about having an off-site replication as a backup strategy?
No, I mean, I sure can, but I'm not sure if it's related to XtraDB cluster, and it is quite big topic. So I'm not sure how to answer it in a short period of time.
Okay, we'll save that one for another webinar. Next question is, MySQL 5.5 required, or does XtraDB cluster work with MySQL 5.1?
So we just recently, just yesterday, we had Percona XtraDB Cluster release 5.5.20. And from name, you can understand it is based on MySQL 5.5.
Okay, very good. Would you recommend setting the cluster group communication on a separate independent subnet like Oracle RAC?
It depends on your individual needs. Yes, of course, the less network disruption you have for internal communication, the better it will be. And I understand it may be not possible in all cases. That's why I do not put it as a recommended configuration. But if you can have some dedicated network setup for explicitly for cluster communication, it will be better.
Okay. Next question is there a project roadmap available for XtraDB cluster?
On this point, we to follow development of Codership, that we take fixes and features that are available in the Galera library that you need to look on Codership website for a roadmap for Galera library. Well, unfortunately, as I remember, there is no public roadmap available at this point of time, but I'm going to have a conversation with Codership guys to make that roadmap publicly available.
Okay. Next question. How would you handle an XtraDB cluster return to service if all the nodes in a cluster were unexpectedly to go offline, such as with a data center UPS failure?
Again, if one node temporarily goes out of cluster, it gets disconnected from cluster, and when it comes back online, it can use one of two connecting methods, incremental state transfer or full state transfer. Incremental can be used if a node was disconnected for a short period of time, and if it was offline for a long time already, it will need to copy full data set.
All right. How do I connect to the cluster? Is it via virtual IP address?
No, you actually can connect, if you don't use a load balancer, you connect to any node, to any IP address from any node. You just connect to MySQL using just a regular MySQL clients or PHP script or Python script, and you use just a regular MySQL connect call using IP address for any nodes in cluster. If you use load balancer, you use IP address of load balancer.
Okay. Can XtraDB cluster be used in geographic redundancy setups? For example, one node in different geographic data centers if the link between the data centers is 1G?
Yes, and actually I'm looking to recommend such setups, but again we need to look into latency requirements, because latency might increase if you have a geographic distribution. If it is a write intensive application and latency is critical, it may be not best choice. But I expect for most setup for small offices, for example, it may be not the big requirement, and to have data consistency between two offices, same in Boston and San Francisco, you actually can use XtraDB cluster for that purpose. And there can be used different schemas for this setup. This is not covered in this webinar, but again, the talk, I know the talk will be on MySQL user conference, and slides from that talk will be available after user conference. So you can use into that talk to understand what kind of setup you can use.
Okay, next question. Is there any chance to get any significant write scaling if we use a manual partitioning approach for highly mutable data? So, for example, write for particular keys are routed to the particular machine.
Not at this point. Again, at this stage, you need to have the same data set on each node, and every single write is replicated to every single node. That whatever partitioning schema you use, it will not help. But we are looking with the Codership team what we can do to provide better write scalability.
All right. Does XtraDB cluster require a specific bin log format?
No, XtraDB cluster requires, by default, it uses a raw bin log format. It also can be used with a statement raw format. And again, by default, row-based replication is used. And the cluster for some specific statements can switch automatically to statement-based events.
Okay. Is the latest release of XtraDB cluster production ready?
Yes, I believe it is. But for any new solution, I don't expect you just install it on production system without testing. I mean, when you use a new product, you usually test in your QA or staging environment, and that's what I expect people will do trying to use XtraDB cluster.
Okay. Can LVM, Logical Volume Manager Snapshot, help to load data in XtraDB Cluster?
State transfer method. As I said, right now we're using rsync or extra backup, but it is actually based on scripts. So if you want to use LVM snapshot, you can take a look on existing script, for example, on a script that handles rsync process, and you can write the same script yourself. Well, probably if there's a lot of interest to this snapshot transfer method, we will provide that script from Percona, but we don't have such a plan at this point of time.
Okay. Would Sphinx SE engine be supported, given they are basically just a table definition?
Percona server and Percona XtraDB Cluster, we do not ship Sphinx storage engine, so a fair answer is it is not supported right now. If you install a Sphinx storage engine by yourself in XtraDB cluster, actually it might work or might not work. I cannot answer right now. I did not test it.
Okay. Next question. How is the availability of the cluster affected during a run of extra backup, IST backup on the master node?
How availability? Well, I guess again, when you use extra backup state transfer, in this case, donor is disconnected from cluster for a short period of time, and then I'm speaking about a couple of seconds, and after that it gets connected back to cluster. So I guess availability is not significantly affected.
Okay. Next question. When upgrading, say 5.5.20 to 5.5.22 when it comes out, is it clean to upgrade one node at a time and just to join them back into the cluster?
Yes, unless we introduce some significant changes in Galera library, which I do not expect at this point of time, the upgrade procedure should be quite simple. You take one node out of cluster, upgrade binaries, and connect node back to the cluster. This names rolling upgrade, and it is supported.
Okay, and we've run out of time, so one last question and then we'll wrap up. How easy is it to add XtraDB cluster to a current MySQL master-slave setup?
To add, I'm not fully sure what does that mean to add. Again, just upgrade is a very easy procedure. You just upgrade current binaries to MySQL, to XtraDB cluster binaries, and make a couple configuration changes which available on our documentation, and you should be ready to go.
Okay, very good. Well, thank you, Vadim. So just to remind everyone, we will send out a link to a recording of today's webinar. We'll also, on the page where you find that recording, you'll find a link to today's slides and any documentation that is applicable. And really appreciate everyone's great questions and attentiveness today. Hope to see many of you in Santa Clara next week, where again you'll be able to see Vadim at our booth and also hear him speak some more about Percona XtraDB Cluster. Have a good day. Goodbye.
Thank you. Thank you, everyone.